Question 1. Governance review demonstrates that the organization's current hazard identification and risk assessment processes may not fully align with current regulatory requirements and industry best practices. Which of the following approaches best addresses this finding while ensuring robust and compliant safety management? Option A. Update all written hazard identification and risk assessment procedures to reflect the latest regulatory language, without verifying their practical application or conducting additional personnel training. Option B. Conduct a comprehensive review and enhancement of existing hazard identification and risk assessment methodologies, ensuring alignment with legal obligations and integrating them into the overall governance framework. Option C. Immediately procure and implement a state-of-the-art risk management software solution to automate the identification and assessment of hazards, assuming it will rectify any process deficiencies. Option D. Engage an external safety consulting firm to completely redesign and implement a new hazard identification and risk assessment system, with minimal internal involvement to ensure objectivity. The correct answer is B. Conduct a comprehensive review and enhancement of existing hazard identification and risk assessment methodologies, ensuring alignment with legal obligations and integrating them into the overall governance framework. Explanation. Scenario analysis. This scenario presents a common challenge in safety management, where a recent governance review highlights potential gaps in the organization's hazard identification and risk assessment processes. The challenge lies in determining the most effective and compliant method to address these identified weaknesses. A professional safety practitioner must not only understand the technical aspects of hazard identification and risk assessment, but also how these integrate with legal requirements and organizational governance structures. The pressure to demonstrate improvement and ensure compliance without introducing unnecessary disruption or overlooking critical elements necessitates a strategic and well-reasoned approach. Correct approach analysis. The correct approach involves a systematic reevaluation and enhancement of the existing hazard identification and risk assessment methodologies, ensuring they align with current legal obligations and industry best practices. This includes verifying that the processes are comprehensive, consistently applied, and adequately documented. The focus on integrating these processes with the organization's overall governance framework ensures that risk management is embedded in strategic decision-making and operational oversight. This aligns with the principles of proactive safety management, which is a cornerstone of regulatory compliance and ethical responsibility under frameworks like OSHA General Duty Clause 29 CFR 1910, 141 in the U.S., which mandates employers provide a workplace free from recognized hazards. It also reflects the spirit of continuous improvement inherent in management systems like ISO 45001. Incorrect approaches analysis. One incorrect approach is to solely rely on external consultants to redesign the entire system without significant internal involvement. While consultants can offer expertise, a lack of internal buy-in and understanding can lead to a system that is not effectively implemented or sustained. This can be a regulatory failure if the redesigned system doesn't adequately address specific legal requirements, or if the organization cannot demonstrate its own competence in managing risks. Ethically, it represents an abdication of responsibility for worker safety. Another incorrect approach is to implement a new, complex software solution without first ensuring the underlying processes are sound and that personnel are adequately trained. This can lead to a misapplication of technology, where the tool becomes a substitute for proper risk assessment rather than an aid. This can result in regulatory noncompliance if the software fails to capture critical hazards or if the data it generates is not interpreted correctly, leading to inadequate control measures. It also fails ethically by prioritizing a technological fix over fundamental safety principles. A third incorrect approach is to focus only on updating the written procedures without verifying their practical application or the competency of personnel to execute them. This creates a facade of compliance. Regulatory bodies often look beyond documentation to assess actual safety performance. Failure to implement and enforce procedures can lead to significant legal penalties and, more importantly, preventable incidents. Ethically, this approach prioritizes form over substance, failing to protect workers. Professional reasoning. Professionals should approach such situations by first understanding the scope and nature of the identified gaps through a thorough internal review. This should involve engaging key stakeholders, including management, supervisors, and frontline workers, to gain a comprehensive perspective. The next step is to benchmark the existing processes against relevant legal requirements, e.g., OSHA standards in the U.S. and recognized industry best practices. Based on this assessment, a targeted plan for improvement should be developed, prioritizing actions that address the most significant risks and legal obligations. This plan should include clear objectives, timelines, resource allocation, and metrics for success. Crucially, the plan must incorporate training and competency development for all involved personnel to ensure effective implementation and sustained performance. Continuous monitoring and periodic review are essential to adapt to changing conditions and maintain the effectiveness of the safety management system. Question 2. Process analysis reveals a recurring incident of workers experiencing minor burns from incidental contact with a hot surface on a piece of manufacturing equipment. The current safety protocol involves providing heat-resistant gloves and instructing operators to be mindful of the hot surface. Despite these measures, the incidents persist, albeit with reduced severity. Which of the following represents the most effective and professionally responsible approach to addressing this hazard, aligning with the principles of the hierarchy of controls and OSHA emphasis on hazard elimination and reduction? Option A. Requiring operators to wear enhanced, higher-rated heat-resistant gloves and providing them with specialized tools to handle materials near the hot surface. Option B. Implementing a mandatory daily training session for all operators on the proper use of heat-resistant gloves and safe work practices around the hot surface. Option C. Installing warning signs with clear visual indicators and audible alarms to alert operators when they are approaching the hot surface. Option D. Redesigning the equipment to enclose the hot surface or relocating it to an area where incidental contact is impossible. The correct answer is D. Redesigning the equipment to enclose the hot surface or relocating it to an area where incidental contact is impossible. Explanation. The scenario presents a common challenge in occupational safety, managing a known hazard with a history of incidents. The professional challenge lies in selecting the most effective control measure that not only addresses the immediate risk, but also aligns with the principles of the hierarchy of controls and relevant U.S. regulatory frameworks, specifically OSHA standards. The requirement for deep analysis stems from the need to justify the chosen control based on its position within the hierarchy and its proven effectiveness in preventing recurrence, rather than simply implementing a readily available or less costly solution. The correct approach represents best professional practice because it prioritizes the most effective and sustainable methods for hazard control as mandated by OSHA General Duty Clause and its emphasis on preventing recognized hazards. Elimination or substitution, being at the top of the hierarchy, are inherently the most effective as they remove or reduce the hazard at its source, thereby minimizing the potential for exposure and subsequent incidents. This proactive approach is ethically sound and legally defensible, demonstrating a commitment to worker safety beyond minimal compliance. Implementing administrative controls or relying solely on personal protective equipment, PPE, represents regulatory and ethical failures. Administrative controls, while useful, are less effective because they rely on human behavior and adherence to procedures, which can be inconsistent. OSHA regulations often view administrative controls as a secondary measure when higher-level controls are not feasible. Relying solely on PPE is the least effective control and is considered a last resort by OSHA. It places the burden of protection on the employee and does not eliminate the hazard itself, leaving workers vulnerable to control failures, improper use, or unforeseen circumstances. Ethically, this approach fails to adequately protect workers by not addressing the root cause of the hazard. Professional decision-making in such situations requires a systematic approach. First, identify and thoroughly understand the hazard and its root causes. Then, brainstorm all potential control measures, explicitly considering their placement within the hierarchy of controls. Evaluate each control for its effectiveness, feasibility, cost, and potential for unintended consequences. Prioritize controls from the top of the hierarchy downwards, selecting the most effective and sustainable option that can be implemented. Document the rationale for the chosen control and continuously monitor its effectiveness, being prepared to reevaluate and implement higher-level controls if necessary. Question 3. System analysis indicates a proposal to replace a standard valve with a more cost-effective, slightly different model in a non-PSM covered process. The engineering department states the change is minor and will not affect performance. As the certified safety professional, what is the most appropriate decision-making framework to ensure worker safety and regulatory compliance? Option A. Implement the change immediately to realize the cost savings and address any potential safety issues that may arise after the fact. Option B. Rely solely on the engineering department's technical assessment and approve the change without further safety review, as they are the experts in equipment specifications. Option C. Initiate a formal management of change (MOC) process to evaluate the potential safety impacts of the valve replacement, including hazard identification, risk assessment, and the development of necessary controls before implementation. Option D. Approve the valve replacement based on the engineering department's assurance of its minor nature and cost-saving benefits, assuming no significant safety risks. The correct answer is C. Initiate a formal management of change (MOC) process to evaluate the potential safety impacts of the valve replacement, including hazard identification, risk assessment, and the development of necessary controls before implementation. Explanation. Scenario analysis. This scenario presents a common challenge in safety management where a proposed change, while seemingly minor and cost-saving, has the potential for unforeseen safety consequences. The professional challenge lies in balancing operational efficiency and cost reduction with the paramount responsibility of ensuring worker safety and compliance with regulatory standards. The CSP's role is to critically evaluate the proposed change, not just on its immediate benefits, but on its potential ripple effects throughout the existing safety management system. This requires a proactive, risk-based approach rather than a reactive one. Correct approach analysis. The correct approach involves a thorough, documented management of change (MOC) process that aligns with OSHA Process Safety Management (PSM) Standard 29 CFR 1910, 119 for covered processes, or General Industry Safety and Health Standards 29 CFR 1910 Subpart E for non-covered processes. This process mandates a systematic evaluation of the proposed change's impact on safety, including hazard identification, risk assessment, development of necessary controls, employee training, and documentation. The key is to ensure that the change does not introduce new hazards or compromise existing safeguards. This aligns with the ethical obligation of a safety professional to protect workers and the regulatory requirement to maintain a safe working environment. Incorrect approaches analysis. Implementing the change without a formal MOC review is a direct violation of regulatory requirements and ethical principles. It bypasses the critical steps of hazard identification and risk assessment, potentially exposing workers to unknown dangers. This approach demonstrates a failure to adhere to established safety protocols and a disregard for the systematic approach to safety mandated by OSHA. Relying solely on the engineering department's assurance that the change is minor is insufficient. While engineers are crucial, safety professionals have a distinct responsibility to independently assess safety implications. This approach abdicates the safety professional's core duty and fails to acknowledge that safety considerations may extend beyond purely technical engineering aspects, encompassing human factors, operational procedures, and emergency response. Approving the change based on cost savings alone, without a comprehensive safety review, is a severe ethical and regulatory failure. It prioritizes financial gain over worker well-being, which is fundamentally contrary to the purpose of a CSP and the intent of safety regulations. This demonstrates a lack of professional judgment and a failure to uphold the highest standards of the safety profession. Professional reasoning. Professionals should employ a structured decision-making framework that begins with understanding the proposed change and its context. This involves identifying all relevant stakeholders, including operations, engineering, and affected employees. The next step is to initiate the MOC process, which includes a detailed hazard analysis and risk assessment. This assessment should consider potential impacts on equipment, procedures, training, and emergency preparedness. Based on the risk assessment, appropriate control measures are developed and implemented. Finally, the change is documented, and post-implementation reviews are conducted to ensure the effectiveness of the controls. This systematic, risk-based approach ensures that all potential safety implications are addressed before a change is implemented, thereby protecting workers and ensuring regulatory compliance. Question 4. Process analysis reveals that a newly enacted federal regulation mandates stricter controls for airborne, particulate matter in manufacturing processes. The current dust collection system is aging and may not meet the new threshold. The EHS manager is considering several implementation strategies to achieve compliance. Which of the following strategies best aligns with professional EHS best practices and regulatory expectations? Option A. Immediately procure and install a new, state-of-the-art dust collection system that exceeds the minimum regulatory requirements, without further investigation into the current system's performance or employee input. Option B. Conduct a comprehensive hazard assessment of the current manufacturing processes. Evaluate the performance of the existing dust collection system against the new regulatory limits, and explore a range of control options, including upgrades, modifications, or alternative technologies, while engaging affected employees in the evaluation. Option C. Prioritize the least expensive solution that appears to meet the minimum regulatory threshold, even if it involves a less robust control technology, to conserve company resources for other initiatives. Option D. Rely on historical data and anecdotal evidence from long-term employees regarding the effectiveness of the current dust collection system, assuming it will likely meet the new standards with minor adjustments. The correct answer is A. Immediately procure and install a new, state-of-the-art dust collection system that exceeds the minimum regulatory requirements, without further investigation into the current system's performance or employee input. Explanation. This scenario presents a common implementation challenge in environmental health and safety A's, where a new regulatory requirement necessitates a significant shift in operational practices. The professional challenge lies in balancing compliance with operational efficiency and employee buy-in, especially when the proposed solution is perceived as burdensome. Careful judgment is required to select an approach that not only meets legal obligations, but also fosters a sustainable safety culture. The correct approach represents best professional practice because it prioritizes a thorough, data-driven understanding of the hazard and the effectiveness of control measures before committing to a specific solution. This aligns with the hierarchy of controls, a fundamental EHS principle, and demonstrates due diligence in hazard management. It also emphasizes stakeholder engagement, which is crucial for successful implementation and long-term compliance, reflecting ethical responsibilities to protect workers and the environment. An incorrect approach that focuses solely on immediate, visible compliance without assessing the underlying risks or the effectiveness of controls fails to address the root cause of the hazard. This can lead to superficial compliance that doesn't genuinely improve safety and may result in continued exposure or the need for more costly interventions later. It also risks alienating employees by imposing solutions without their input or understanding, potentially leading to resistance and noncompliance. Another incorrect approach that relies on anecdotal evidence or past practices, without considering the specific nuances of the new regulation or the current operational context, is professionally unsound. This can lead to the selection of ineffective controls or the misapplication of resources. It also fails to demonstrate a proactive and systematic approach to EHS management, which is a cornerstone of professional responsibility. Finally, an approach that prioritizes cost savings over robust hazard control is ethically and regulatorily deficient. While cost-effectiveness is a consideration, it must not compromise the primary duty of care to ensure a safe and healthy workplace and environment. Such an approach can lead to significant legal liabilities, reputational damage, and most importantly, harm to individuals. The professional reasoning process should involve 1. Understanding the regulatory requirements thoroughly. 2. Conducting a comprehensive risk assessment specific to the identified hazard and the new regulation. 3. Evaluating potential control measures based on the hierarchy of controls and their effectiveness. 4. Engaging relevant stakeholders, employees, management, technical experts in the evaluation and selection process. 5. Developing a phased implementation plan with clear metrics for success. 6. Regularly reviewing and updating the EHS program based on performance data and evolving requirements. Question 5. The performance metrics show a consistent upward trend in recordable incidents related to material handling over the past 2 quarters. As the certified safety professional, you need to develop new or revise existing safety policies and procedures to address this trend. Which of the following approaches is the most effective and compliant with U.S. OSHA regulations? Option A. Focus on purchasing new, advanced material handling equipment, believing that technological upgrades will inherently solve the problem without altering current work practices or policies. Option B. Conduct a comprehensive review of current material handling procedures, analyze incident investigation reports to identify common root causes, solicit input from material handling employees on potential hazards and control measures, and then develop specific, actionable policies and procedures with clear training protocols. Option C. Immediately issue a company-wide memo mandating stricter enforcement of existing, but unexamined material handling rules and increasing disciplinary actions for any violations. Option D. Implement a new, generic safe lifting policy that applies to all departments, assuming the issue is primarily due to improper lifting techniques, without further investigation into specific material handling tasks. The correct answer is B. Conduct a comprehensive review of current material handling procedures, analyze incident investigation reports to identify common root causes, solicit input from material handling employees on potential hazards and control measures, and then develop specific, actionable policies and procedures with clear training protocols. Explanation. Scenario analysis. This scenario presents a common challenge in safety management where lagging indicators, performance metrics, reveal a problem, but the root cause is not immediately obvious. The professional's task is to develop effective safety policies and procedures to address this issue. The challenge lies in moving beyond simply reacting to incidents and proactively developing systemic solutions that prevent future occurrences. This requires a deep understanding of the organization's operations, potential hazards, and the principles of effective safety program development, all within the framework of applicable U.S. regulations, specifically OSHA standards. Correct approach analysis. The correct approach involves a systematic, data-driven process that aligns with OSHA emphasis on hazard identification, risk assessment, and the development of effective control measures. This approach begins with a thorough investigation of the identified performance metric trends to understand the underlying causes. It then involves engaging relevant stakeholders, including employees who are directly involved in the work, to gather insights and ensure buy-in. Developing specific, measurable, achievable, relevant, and time-bound, SMART, policies and procedures that address the identified root causes, and then implementing and monitoring them, is a best practice. This aligns with OSHA General Duty Clause 29 CFR 1910-141, which requires employers to provide a workplace free from recognized hazards, and the principles of a robust safety and health management system, such as those outlined in OSHA recommended practices for safety and health programs. Incorrect approaches analysis. One incorrect approach involves immediately implementing a broad, generic policy without understanding the specific causes of the performance metric trends. This fails to address the actual hazards or deficiencies, making the policy ineffective and a waste of resources. Ethically, it demonstrates a lack of due diligence and a failure to protect employees. From a regulatory standpoint, it does not fulfill the employer's obligation under OSHA to provide a safe workplace, as it's a reactive measure without a clear link to hazard control. Another incorrect approach is to solely rely on management directives without employee input. This often leads to policies that are impractical, difficult to follow, or perceived as unfair, resulting in poor compliance and a lack of ownership. This violates the spirit of collaborative safety culture that OSHA encourages and can be seen as a failure to adequately involve the workforce in hazard identification and control, a key component of effective safety programs. A third incorrect approach is to focus only on disciplinary actions for employees when performance metrics decline. While accountability is important, a sole reliance on discipline without addressing systemic issues or providing adequate training and resources is a flawed strategy. It creates a climate of fear rather than a proactive safety culture, and fails to identify and correct the root causes of incidents or near misses. This approach is not aligned with OSHA focus on hazard prevention and control. Professional reasoning. When faced with declining performance metrics, a safety professional should employ a structured problem-solving approach. This involves 1. Data analysis. Thoroughly examine the performance metrics to identify trends and potential contributing factors. 2. Root cause analysis. Conduct investigations, e.g., incident investigations, job hazard analyses to determine the underlying causes of the observed trends. 3. Stakeholder engagement. Involve employees, supervisors, and management in the analysis and solution development process. 4. Policy and procedure development. Create specific, actionable, and relevant safety policies and procedures that directly address the identified root causes. 5. Implementation and training. Effectively communicate and train employees on the new or revised policies and procedures. 6. Monitoring and evaluation. Continuously monitor the effectiveness of the implemented policies and procedures through ongoing data collection and feedback. 7. Continuous improvement. Use the evaluation results to make necessary adjustments and improvements to the safety program. Question 6. Assessment of a safety performance report for a manufacturing facility reveals a mixed bag of data. While the number of recordable incidents has decreased over the past year, there has been a significant increase in reported near misses and a concerning rise in the number of identified hazards during routine inspections. The company's executive team is preparing for a board meeting and has requested a presentation that highlights the positive trend in incident reduction. The safety manager is considering how to best present this information to emphasize the company's safety achievements. Which of the following approaches best aligns with professional safety practice and ethical obligations? Option A. Emphasize the positive trend in incident reduction and suggest that the increase in near misses and identified hazards is likely due to improved reporting culture, which is a positive outcome in itself, thereby downplaying the underlying safety concerns. Option B. Present a comprehensive overview of all collected safety data, including both lagging indicators, recordable incidents, and leading indicators, near misses, identified hazards, explaining the trends in each and the interconnectedness of these metrics in assessing overall safety performance. Option C. Focus the presentation solely on the decrease in recordable incidents, framing it as a direct result of the company's effective safety programs, and briefly mention that near misses and hazard reports are being addressed without detailing the increase. Option D. Recommend that the data on near misses and identified hazards be smoothed or presented in a way that minimizes the visual impact of the increase to ensure a consistently positive narrative for the board meeting. The correct answer is B. Present a comprehensive overview of all collected safety data, including both lagging indicators, recordable incidents, and leading indicators, near misses, identified hazards, explaining the trends in each and the interconnectedness of these metrics in assessing overall safety performance. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in performance evaluation, where a safety professional is pressured to present data in a way that might not fully reflect the reality of safety performance. The challenge lies in balancing the need to report accurate, objective data with external pressures to present a more favorable picture. This requires a strong understanding of professional ethics and the specific regulatory requirements for reporting safety performance. The pressure to manipulate data, even subtly, can compromise the integrity of the safety management system and lead to poor decision-making. Correct approach analysis. The correct approach involves a commitment to data integrity and transparency, aligning with the core principles of professional conduct for certified safety professionals. This means presenting all relevant data, including leading and lagging indicators, without omission or alteration, and providing context for any trends observed. This approach upholds the ethical obligation to provide accurate information to stakeholders, enabling informed decision-making and continuous improvement. It directly supports the intent of regulatory frameworks like OSHA General Duty Clause, which requires employers to provide a workplace free from recognized hazards, necessitating accurate assessment of risks. Ethical codes for safety professionals emphasize honesty, objectivity, and the pursuit of truth in reporting. Incorrect approaches analysis. Presenting only positive trends and omitting negative data or near misses is ethically flawed because it creates a misleading picture of safety performance. This violates the principle of transparency and can lead to complacency, masking underlying issues that require attention. From a regulatory standpoint, this omission could be seen as a failure to adequately identify and address hazards, potentially contravening OSHA requirements for hazard assessment and control. Focusing solely on lagging indicators and downplaying the significance of leading indicators, even if the lagging indicators show improvement, is also problematic. Leading indicators are crucial for proactive hazard identification and risk mitigation, Ignoring them means failing to leverage the most effective tools for preventing future incidents. Ethically, this represents a superficial approach to safety management, prioritizing the appearance of success over genuine risk reduction. Suggesting that the data be smoothed or adjusted to present a more consistent upward trend, even without explicit falsification, is a form of data manipulation. This undermines the objectivity of the performance evaluation and can lead to flawed strategic decisions based on artificially improved metrics. It violates the ethical duty of honesty and integrity in professional practice and could be interpreted as a deliberate attempt to mislead stakeholders about the true state of safety. Professional reasoning. Professionals should approach performance evaluation with a commitment to objectivity and truthfulness. When faced with pressure to alter data, the decision-making process should involve 1. Clearly understanding the purpose of the evaluation and the data being collected. 2. Identifying all relevant data, both positive and negative leading and lagging indicators. 3. Analyzing the data objectively, seeking to understand the root causes of trends. 4. Communicating findings transparently, providing context and explanations for any observed patterns. And 5. If faced with pressure to misrepresent data, consulting professional codes of ethics, seeking guidance from professional organizations, and, if necessary, escalating concerns through appropriate channels within the organization. The ultimate goal is to ensure that performance evaluations drive genuine safety improvements, not just favorable reporting. Question 7. Comparative studies suggest that when a diverse group of stakeholders, including management, frontline workers, and regulatory compliance officers, need to understand and act upon identified workplace hazards, the choice of risk assessment methodology significantly impacts the effectiveness of subsequent control measures. Considering the need for both systematic evaluation and clear communication across these groups, which risk assessment approach is most likely to facilitate informed decision-making and demonstrable due diligence within a U.S. regulatory framework? Option A. A semi-quantitative approach that assigns numerical or categorical ratings to likelihood and severity, allowing for a tiered prioritization of risks. Option B. A highly quantitative approach that requires extensive data collection and complex statistical modeling to assign precise probability values and financial impact. Option C. A purely qualitative approach that relies on expert judgment and descriptive categories to identify and rank hazards based on perceived risk. Option D. A consensus-based approach where stakeholders collectively agree on the presence and significance of hazards without formal evaluation criteria. The correct answer is A. A semi-quantitative approach that assigns numerical or categorical ratings to likelihood and severity, allowing for a tiered prioritization of risks. Explanation. This scenario presents a common challenge in occupational safety and health management, selecting the most appropriate risk assessment methodology when faced with diverse stakeholder needs and varying levels of available data. The professional challenge lies in balancing the rigor of the assessment with the practical constraints of time, resources, and the need for actionable insights that resonate with different groups. A safety professional must demonstrate not only technical competence in risk assessment, but also strong communication and stakeholder management skills. The correct approach, focusing on a semi-quantitative methodology, represents best professional practice because it offers a structured yet adaptable framework. It allows for the systematic identification and evaluation of hazards, assigning a level of risk that can be communicated effectively to both technical and non-technical stakeholders. This approach often aligns with regulatory expectations, e.g., OSHA General Duty Clause, which implicitly requires employers to identify and mitigate recognized hazards by providing a defensible basis for prioritizing control measures. Ethically, it demonstrates due diligence by moving beyond mere identification to a reasoned evaluation of risk severity and likelihood, facilitating informed decision-making for resource allocation and intervention strategies. An incorrect approach that relies solely on qualitative methods, while useful for initial hazard identification, fails to provide the necessary depth for effective prioritization when resources are limited. This can lead to overlooking significant risks or overemphasizing minor ones, potentially violating the employer's ethical obligation to protect workers. It may also fall short of regulatory expectations for a robust risk management program. Another incorrect approach, focusing exclusively on a highly quantitative methodology without sufficient data or expertise, can be overly time-consuming and resource-intensive, leading to analysis paralysis. This can delay necessary interventions, potentially exposing workers to undue risk and failing to meet the spirit of regulatory requirements for timely hazard control. Furthermore, the complexity of such an assessment might alienate stakeholders who cannot readily understand or act upon its findings. The professional decision-making process for similar situations should involve 1. Understanding the organizational context, including available resources, expertise, and the nature of the hazards. 2. Identifying and engaging key stakeholders to understand their perspectives, needs, and the level of detail they require. 3. Evaluating the suitability of different risk assessment methodologies against these contextual factors and stakeholder requirements. 4. Selecting a methodology that provides a balance of rigor, practicality, and communicability, ensuring it supports informed decision-making and compliance with relevant regulations. Question 8. Market research demonstrates that chemical used in a manufacturing process has an OSHA permissible exposure limit (PEL) of 10 parts per million ppm and an ECG threshold limit value (TLV) of 5 ppm, both as an 8-hour time-weighted average. The company has been operating within the PEL, but has not yet implemented controls to meet the TLV. As the certified safety professional responsible for the facility, what is the most appropriate course of action regarding worker exposure to this chemical? Option A. Rely on personal protective equipment (PPE) to ensure worker exposure remains below the PEL, as this is a common and acceptable practice. Option B. Continue to monitor worker exposure and ensure it remains below the PEL of 10 ppm, as this is the legally enforceable standard. Option C. Implement engineering and administrative controls to reduce worker exposure to the TLV of 5 ppm, as it represents a more protective guideline based on current scientific understanding. Option D. Conduct a cost-benefit analysis to determine if the expense of reducing exposure to the TLV is justified by the potential health benefits. The correct answer is C. Implement engineering and administrative controls to reduce worker exposure to the TLV of 5 ppm, as it represents a more protective guideline based on current scientific understanding. Explanation. Scenario analysis. This scenario presents a common challenge in industrial hygiene and safety management: the presence of a chemical with both a permissible exposure limit (PEL) and a threshold limit value (TLV). The professional challenge lies in determining which standard to prioritize for worker protection, especially when the TLV is more stringent than the PEL. This requires understanding the legal enforceability of each standard and the ethical obligation to provide the highest practicable level of safety. The decision impacts resource allocation, control measure implementation, and potential liability. Correct approach analysis. The correct approach prioritizes the more protective standard, which in this case is the TLV. While OSHA PELs are legally enforceable in the U.S., they represent minimum legal requirements. The American Conference of Governmental Industrial Hygienists, ECG TLVs, are developed based on current scientific information and are widely recognized as best practice guidelines. Ethically and professionally, a safety professional has a duty to protect workers from recognized hazards to the fullest extent possible, which often means exceeding minimum legal requirements when better guidance is available. Adopting the TLV demonstrates a proactive and best practice approach to worker health and safety, aligning with the spirit of the OSH Act's General Duty Clause to provide a workplace free from recognized hazards. Incorrect approaches analysis. One incorrect approach is to solely adhere to the PEL. This is a regulatory failure because it neglects the availability of a more protective guideline, the TLV, that represents current scientific consensus on safe exposure levels. Ethically, it falls short of the professional obligation to provide the highest practicable level of safety. Another incorrect approach is to ignore both the PEL and the TLV, relying instead on general industry practice without specific data. This is a significant professional and ethical failure. It demonstrates a lack of due diligence in hazard assessment and control, potentially exposing workers to unacceptable risks and violating the General Duty Clause. A third incorrect approach is to assume that because the PEL is a legal standard, it is the only one that matters. This misunderstands the role of professional judgment and best practices in safety management. While PELs are enforceable, they are not necessarily the most protective standards available, and safety professionals are expected to utilize all available relevant information to ensure worker safety. Professional reasoning. When faced with differing exposure limits for a substance, a safety professional should first identify the applicable legal limits, PELs, in the U.S. Concurrently, they should research and evaluate recommended exposure limits from reputable organizations like ECG, TLV. The professional decision-making process involves comparing these limits and selecting the most protective one for implementation. This decision should be documented, and control measures should be designed and implemented to meet this chosen limit. Communication with management regarding the rationale for selecting the more protective limit and the associated resource implications is also crucial. The overarching principle is to prioritize worker health and safety based on the best available scientific and professional guidance, even if it exceeds minimum legal requirements. Question 9. To address the challenge of optimizing airborne contaminant sampling in a manufacturing facility with recently modified production lines, which approach best ensures accurate exposure assessment and regulatory compliance? Option A. Implement sampling only at locations where visible dust or fumes are readily apparent, disregarding less obvious potential emission sources. Option B. Conduct a detailed walkthrough survey to understand current operations, identify potential exposure points, and review existing process documentation and any prior exposure monitoring data to inform the selection of appropriate sampling methods and locations. Option C. Prioritize sampling the smallest possible number of workers to reduce analytical costs without a specific risk-based justification for the reduced sample size. Option D. Rely exclusively on historical exposure monitoring data from previous years, assuming the recent production line modifications have had minimal impact on airborne contaminant levels. The correct answer is B. Conduct a detailed walkthrough survey to understand current operations, identify potential exposure points, and review existing process documentation and any prior exposure monitoring data to inform the selection of appropriate sampling methods and locations. Explanation. The scenario presents a common challenge in industrial hygiene, optimizing an airborne contaminant sampling strategy to ensure worker protection while managing resources effectively. The challenge lies in balancing the need for accurate exposure assessment with the practical constraints of time, cost, and the dynamic nature of workplace exposures. A professional safety practitioner must apply a systematic, risk-based approach that aligns with regulatory requirements and best practices. The correct approach represents best professional practice because it prioritizes a thorough understanding of the process and potential hazards before selecting sampling methods. This aligns with the principles of industrial hygiene, which emphasize proactive hazard identification and control. By conducting a walkthrough survey and reviewing existing data, the safety professional can make informed decisions about the most appropriate sampling techniques, e.g., personal vs. area sampling, specific analytical methods, and the number of samples needed to achieve statistical significance, thereby ensuring compliance with OSHA standards and protecting worker health. This approach is ethically sound as it demonstrates due diligence and a commitment to worker safety. An incorrect approach that relies solely on historical data without considering recent process changes fails to acknowledge the dynamic nature of workplace exposures. This could lead to an inaccurate assessment of current risks, potentially resulting in noncompliance with permissible exposure limits, PEL, and inadequate worker protection. Ethically, this demonstrates a lack of diligence and a failure to adapt to evolving conditions. Another incorrect approach that focuses only on the most visible or easily accessible emission sources overlooks potential, less obvious sources of exposure. This can lead to a skewed sampling strategy that does not capture the full range of worker exposures, violating the principle of comprehensive hazard assessment. Regulatory failure occurs because the sampling plan would not adequately represent actual exposure conditions, potentially leading to noncompliance with OSHA General Duty Clause and specific substance standards. Finally, an approach that prioritizes sampling the fewest number of workers to minimize cost, without a risk-based justification, is also professionally unacceptable. This approach prioritizes cost savings over worker protection and may not provide a representative sample of the workforce, especially if exposure levels vary significantly among individuals. This directly contravenes the ethical obligation to protect all workers and can lead to regulatory violations if significant overexposures are missed. Professionals should employ a decision-making framework that begins with a comprehensive understanding of the work processes, potential contaminants, and existing control measures. This is followed by a risk assessment to prioritize hazards and determine the level of sampling rigor required. The selection of sampling methods and strategies should be based on this risk assessment, regulatory requirements, e.g., OSHA sampling guidelines, and the specific characteristics of the contaminants and work environment. Continuous evaluation and adjustment of the sampling plan based on initial results and changing conditions are also crucial. Question 10. Operational review demonstrates that while a comprehensive set of safety training modules, hazard communication plans, and safety committee meetings are in place, there is a noticeable disconnect between the documented procedures and the day-to-day practices observed on the shop floor. Which of the following approaches best addresses this gap to ensure effective support for safety? Option A. Increase the frequency of safety committee meetings and mandate additional training sessions on the existing documented procedures to reinforce their importance. Option B. Rely on the fact that no major incidents have occurred in the past year as evidence that the current support mechanisms are sufficient and effective. Option C. Allocate additional budget for new safety equipment and personal protective devices, assuming that improved physical resources will automatically enhance safety practices. Option D. Conduct a series of targeted employee surveys and direct observation audits to assess the practical application of safety knowledge and the effectiveness of communication channels in translating documented procedures into safe behaviors. Correct answer is D. Conduct a series of targeted employee surveys and direct observation audits to assess the practical application of safety knowledge and the effectiveness of communication channels in translating documented procedures into safe behaviors. Explanation. This scenario presents a common challenge in safety management, ensuring that the necessary resources, competence, awareness, and communication are effectively in place to support safety initiatives. The professional challenge lies in accurately assessing the impact of existing support mechanisms on actual safety performance and identifying gaps that could lead to incidents. A superficial review might overlook subtle but critical deficiencies. The correct approach focuses on a proactive and data-driven impact assessment. This aligns with the principles of continuous improvement and due diligence mandated by regulatory frameworks such as OSHA General Duty Clause 29 U.S. Code Section 654. 1. Which requires employers to provide a workplace free from recognized hazards. An impact assessment, when conducted rigorously, directly evaluates whether the provided resources are adequate, if personnel possess the necessary competence, if awareness programs are effective in changing behavior, and if communication channels are functioning to disseminate critical safety information. This approach demonstrates a commitment to understanding the effectiveness of safety management systems and making informed decisions for improvement, which is a cornerstone of professional safety practice. An incorrect approach that relies solely on the presence of safety programs without evaluating their impact is a significant regulatory and ethical failure. For instance, simply having a training manual presence without verifying if employees understand and apply the training impact fails to meet the spirit and often the letter of regulations requiring effective hazard communication and training. Similarly, allocating a budget for safety equipment presence without assessing if the equipment is used correctly or if it effectively mitigates identified risks impact is a failure of due diligence. Ethically, it represents a superficial commitment to safety, potentially exposing workers to undue risk. Another incorrect approach might involve assuming that because no recent incidents have occurred, the current support mechanisms are adequate. This reactive stance ignores the potential for latent failures and the proactive nature of effective safety management required by regulations. The professional reasoning process for similar situations should involve a systematic approach to impact assessment. This begins with clearly defining the objectives of the safety support mechanisms. Next, relevant metrics and indicators should be identified to measure the effectiveness of resources, competence, awareness, and communication. Data collection should be comprehensive, including observations, interviews, incident data, and performance metrics. The collected data must then be analyzed to determine the actual impact on safety performance. Finally, based on this analysis, targeted interventions and improvements should be developed and implemented, with a feedback loop to continuously monitor their effectiveness. This iterative process ensures that safety support is not just a formality, but a dynamic and effective component of the overall safety management system. Question 11. The assessment process reveals that while a behavior-based safety (BBS) program has been in place for 2 years, incident rates have plateaued, and frontline workers express skepticism about management's genuine commitment to the program's principles, often viewing it as a compliance exercise. What is the most effective approach for the safety professional to revitalize the BBS program and foster a more robust safety culture? Option A. Facilitate a series of workshops involving workers and supervisors to collaboratively review and refine the BBS observation process, develop clear communication strategies for feedback, and establish visible management accountability for addressing identified at-risk behaviors and system issues. Option B. Engage an external BBS consulting firm to conduct a complete overhaul of the program, assuming that external expertise will bring the necessary objectivity and innovation to address the current challenges. Option C. Increase the frequency of BBS observations and implement stricter disciplinary actions for employees observed engaging in at-risk behaviors to ensure compliance and deter future occurrences. Option D. Conduct a comprehensive review of the BBS program's theoretical underpinnings and update all training materials to emphasize the scientific principles of behavior modification, without significant changes to current implementation practices. The correct answer is A. Facilitate a series of workshops involving workers and supervisors to collaboratively review and refine the BBS observation process, develop clear communication strategies for feedback, and establish visible management accountability for addressing identified at-risk behaviors and system issues. Explanation. The assessment process reveals a common challenge in behavior-based safety (BBS) implementation: the disconnect between management's perceived commitment and the frontline workers' lived experience. This scenario is professionally challenging because it requires the safety professional to bridge this gap, ensuring that BBS is not just a program on paper, but a genuinely integrated part of the safety culture. The safety professional must navigate differing perspectives, potential resistance, and the need for credible leadership buy-in, all while adhering to the principles of effective BBS and relevant U.S. regulations, such as OSHA General Duty Clause 29 U.S.C. Section 654(a)(1), which mandates employers provide a workplace free from recognized hazards. The correct approach represents best professional practice because it directly addresses the root cause of the observed disconnect. By involving workers in the design and refinement of BBS, fostering open communication channels for feedback, and ensuring visible management support and accountability, the safety professional builds trust and ownership. This aligns with the ethical responsibility to involve those most affected by safety programs and the regulatory expectation that safety initiatives are practical and effective in hazard recognition and control. This approach promotes a sustainable BBS program that is more likely to achieve its intended outcomes of reducing incidents. An incorrect approach that focuses solely on increasing observation rates without addressing the underlying issues of worker perception or management commitment is ethically flawed. It prioritizes a quantitative metric over qualitative effectiveness, potentially leading to superficial compliance rather than genuine behavioral change. This could be seen as a failure to adequately identify and mitigate hazards, as the program is not truly addressing the systemic issues contributing to unsafe behaviors or the perception of a lack of genuine commitment. Another incorrect approach that relies on punitive measures for observed at-risk behaviors, rather than focusing on understanding and correcting the root causes, is also ethically problematic. This can foster fear and discourage reporting, undermining the core principles of BBS, which emphasize positive reinforcement and learning. Such an approach fails to uphold the employer's duty to foster a safe and open reporting environment, potentially violating the spirit, if not the letter, of regulations that encourage proactive hazard identification and correction. Finally, an approach that solely relies on external consultants to design and implement the BBS program without significant internal stakeholder involvement risks creating a program that is not tailored to the specific organizational context or accepted by the workforce. While consultants can offer expertise, a lack of internal buy-in and ownership will likely lead to its failure. This represents a failure in professional due diligence to ensure the program's long-term viability and effectiveness. The professional decision-making process for similar situations should involve a thorough root cause analysis of the observed disconnect. This includes actively soliciting feedback from all levels of the organization, particularly frontline workers. The safety professional should then use this information to collaboratively develop or refine the BBS program, ensuring it is practical, relevant, and supported by visible leadership commitment. Regular evaluation of both the process and outcomes, with a focus on continuous improvement, is crucial. Question 12. Quality control measures reveal that the local exhaust ventilation (LEV) system installed to capture welding fumes at a fabrication shop has not been quantitatively assessed for effectiveness since its initial installation 2 years ago, despite increased production volume and the introduction of new welding alloys. Workers have not reported any specific symptoms related to fume exposure. Which of the following represents the most appropriate and compliant course of action for the certified safety professional to ensure ongoing worker protection from airborne hazards? Option A. Increase the general dilution ventilation rate throughout the fabrication shop to compensate for any potential deficiencies in the LEV system. Option B. Rely on the fact that no workers have reported symptoms, assuming the current LEV system is adequately controlling exposures. Option C. Conduct periodic quantitative testing of the LEV system's airflow and capture velocity, and perform personal air monitoring for welders to verify exposure levels are below permissible exposure limits, PEL. Option D. Perform only a visual inspection of the LEV hoods and ductwork to ensure there are no obvious blockages or damage. The correct answer is C. Conduct periodic quantitative testing of the LEV system's airflow and capture velocity, and perform personal air monitoring for welders to verify exposure levels are below permissible exposure limits, PEL. Explanation. This scenario presents a common implementation challenge in industrial hygiene, ensuring the effectiveness of engineering controls, specifically local exhaust ventilation, LEV, in a dynamic work environment. The challenge lies in moving beyond initial design and installation to ongoing verification and adaptation, which is critical for maintaining worker protection. The professional difficulty arises from balancing operational demands with the non-negotiable requirement for a safe atmosphere, especially when initial assumptions about contaminant generation or airflow may no longer hold true. The correct approach, which involves periodic quantitative assessment of LEV system performance and worker exposure levels, represents best professional practice because it directly aligns with the hierarchy of controls and regulatory mandates. OSHA General Duty Clause, Section 5(a)(1) of the OSH Act, requires employers to provide a workplace free from recognized hazards. Furthermore, specific standards, such as those for respiratory protection, 29 CFR 1910, 134, and air contaminants, 29 CFR 1910, 1000, implicitly or explicitly require effective engineering controls to be the primary means of hazard reduction. Regular monitoring and reevaluation ensure that the LEV system continues to meet design specifications and effectively controls airborne hazards below permissible exposure limits PEL. This proactive stance prevents potential overexposures and demonstrates due diligence. An incorrect approach that relies solely on visual inspection of airflow is professionally unacceptable due to its inherent limitations. Visual cues are subjective and can be misleading. They do not provide a quantitative measure of contaminant capture efficiency or airflow volume. This approach fails to meet the regulatory expectation for verifiable control effectiveness and could lead to a false sense of security, violating the employer's duty to protect workers. Another incorrect approach, which involves only addressing ventilation issues when workers report symptoms, represents a reactive and ethically deficient strategy. This approach ignores the principle of preventing exposure before harm occurs and is a clear violation of the employer's responsibility to identify and mitigate hazards proactively. Relying on symptom reporting means that overexposures have already occurred, potentially leading to acute or chronic health effects, and it fails to meet the standard of care expected of a safety professional. Finally, an approach that focuses on increasing the supply of general dilution ventilation as a primary solution for localized airborne hazards is often ineffective and inefficient. While general ventilation plays a role in overall air quality, it is not a substitute for LEV when dealing with specific point sources of contamination. Dilution ventilation may not adequately capture contaminants at the source, can be energy intensive, and may not bring concentrations below PELs for highly toxic substances. This approach fails to implement the most effective control strategy according to the hierarchy of controls and regulatory intent. Professionals should employ a decision-making framework that prioritizes the hierarchy of controls: elimination, substitution, engineering controls, administrative controls, and personal protective equipment, PPE. For airborne hazards, engineering controls like LEV are paramount. The process should involve 1. Hazard identification and characterization. 2. Selection of appropriate control measures based on the hierarchy. 3. Design and implementation of controls. 4. Verification of control effectiveness through quantitative monitoring and exposure assessment. And 5. Periodic reevaluation and maintenance to ensure continued efficacy. This systematic, data-driven approach ensures compliance and worker safety. Question 13. Consider a scenario where a manufacturing facility has identified a specific welding operation that utilizes a new alloy containing potentially hazardous fumes. The safety professional needs to assess worker exposure to these fumes to ensure compliance with OSHA standards. The welding operation occurs intermittently throughout the day, and the specific welders performing the task rotate. The facility has existing air monitoring equipment that can measure general air quality in the work area, but deploying it directly on workers for extended periods might interfere with their tasks. What is the most appropriate strategy for assessing worker exposure to the welding fumes? Option A. Rely on existing area air monitoring data collected in the general vicinity of the welding operation, assuming it reflects typical worker exposure levels. Option B. Perform air monitoring only during times when the welding operation is not actively occurring or when fewer welders are present to minimize disruption. Option C. Conduct personal exposure monitoring on a representative sample of welders performing the specific operation during their actual work shifts, focusing on periods of peak fume generation. Option D. Utilize historical exposure data from similar welding operations conducted in the past, without performing new monitoring. The correct answer is C. Conduct personal exposure monitoring on a representative sample of welders performing the specific operation during their actual work shifts, focusing on periods of peak fume generation. Explanation: this scenario presents a common implementation challenge in industrial hygiene, balancing the need for accurate exposure data with practical constraints like worker availability and operational disruption. The professional challenge lies in selecting an exposure assessment strategy that is both scientifically sound and operationally feasible, while remaining compliant with regulatory requirements. This requires a deep understanding of the nuances between personal and area monitoring and their respective applications under OSHA standards. The correct approach represents best professional practice because it prioritizes personal exposure monitoring for the specific task identified as having the highest potential for exposure. OSHA Personal Protective Equipment, PPE, Standards 29 CFR 1910, 132, and Respiratory Protection Standards 29 CFR 1910, 134 implicitly require employers to assess actual worker exposure to determine the need for and type of controls, including PPE. Personal monitoring directly measures what an individual worker inhales, providing the most accurate data for assessing compliance with permissible exposure limits (PEL) and for selecting appropriate respiratory protection. This aligns with the hierarchy of controls, where understanding actual exposure informs the selection of effective controls. An incorrect approach that relies solely on area monitoring fails to adequately assess individual worker exposure. While area monitoring can provide valuable information about general environmental conditions and the effectiveness of engineering controls, it does not account for variations in individual work practices, proximity to the source, or the duration of exposure for specific tasks. OSHA Hazard Communication Standard 29 CFR 1910, 1200, and specific substance standards often require employers to ensure that worker exposures are below established limits, which is best achieved through personal monitoring when significant exposure potential exists. Relying only on area monitoring could lead to underestimation of individual exposures, potentially resulting in noncompliance and inadequate protection for workers. Another incorrect approach that focuses only on historical data without current assessment is professionally deficient. While historical data can inform initial risk assessments, it is not a substitute for current exposure monitoring, especially when processes change, new materials are introduced, or there's a suspicion of increased exposure. Regulatory compliance requires employers to actively assess and control hazards, not rely on outdated information. A third incorrect approach that prioritizes convenience over accuracy by only monitoring during non-peak hours or when fewer workers are present would be a significant ethical and regulatory failure. This approach deliberately avoids collecting data during periods of highest potential exposure, leading to a skewed and inaccurate representation of actual worker risk. This directly contravenes the employer's general duty to provide a safe and healthful workplace under the OSH Act, which necessitates a thorough and representative assessment of hazards. The professional decision-making process for similar situations should involve 1. Identifying the specific task or process with potential for exposure. 2. Reviewing available information, including safety data sheets, SDS, and existing monitoring data. 3. Determining the most appropriate monitoring strategy based on the nature of the hazard, the task, and regulatory requirements, prioritizing personal monitoring when direct worker exposure is a concern. 4. Considering operational constraints and worker availability, but ensuring that these do not compromise the integrity or representativeness of the exposure assessment. 5. Documenting the rationale for the chosen strategy and the findings. Question 14. The investigation demonstrates that a construction company's safety program, while meeting the minimum requirements of OSHA standards for fall protection and electrical safety, has experienced a recent increase in minor injuries related to material handling and housekeeping. The safety manager is considering two primary approaches for revising the program. One, focusing on developing more detailed checklists and inspection forms for all tasks, and another emphasizing a comprehensive risk assessment of all operational areas to identify and control the root causes of the recent incidents. Which approach best aligns with the principles of effective safety program development and implementation under U.S. regulatory frameworks? Option A. Implementing a comprehensive risk assessment process to identify and control the root causes of the recent incidents. Option B. Focusing solely on updating the company's written safety manual to reflect the latest OSHA compliance updates. Option C. Relying primarily on employee suggestions for safety improvements without formal hazard identification or risk analysis. Option D. Developing more detailed checklists and inspection forms for all tasks to ensure strict adherence to existing OSHA standards. The correct answer is A. Implementing a comprehensive risk assessment process to identify and control the root causes of the recent incidents. Explanation. The investigation demonstrates a common challenge in safety program development: the tension between a prescriptive, compliance-driven approach and a proactive, risk-based approach. The professionally challenging aspect lies in determining the most effective and sustainable method for achieving and maintaining a safe work environment, especially when faced with limited resources or competing priorities. Careful judgment is required to balance regulatory mandates with the practical realities of operational safety. The correct approach represents best professional practice because it aligns with the fundamental principles of modern safety management, which emphasize understanding and controlling hazards before they cause harm. This proactive stance is not only more effective in preventing incidents, but also aligns with the spirit of regulations like OSHA General Duty Clause, which requires employers to provide a workplace free from recognized hazards. A risk-based approach fosters a culture of continuous improvement and adaptability, essential for long-term safety success. An incorrect approach that relies solely on a checklist-driven, compliance-focused method fails to address the unique hazards and operational context of the specific workplace. This can lead to a false sense of security, where compliance is achieved on paper, but actual risks remain unmitigated. Ethically, this approach can be seen as a minimal effort to meet legal obligations rather than a genuine commitment to worker well-being. Another incorrect approach, focusing only on past incident data without considering emerging or potential future risks, is reactive and insufficient. It fails to anticipate and prevent new hazards, leaving the organization vulnerable. This can be a regulatory failure if it results in a failure to identify and control recognized hazards. A third incorrect approach, prioritizing cost savings over comprehensive safety measures, represents a significant ethical and regulatory failure. It directly contravenes the employer's responsibility to provide a safe workplace and can lead to severe consequences, including serious injuries, fatalities, and substantial legal penalties. Professionals should employ a decision-making framework that begins with a thorough hazard identification and risk assessment process. This involves understanding the specific operations, potential failure modes, and the likelihood and severity of potential harm. The next step is to develop control measures that are prioritized based on the hierarchy of controls. Regulatory requirements should be integrated into this process, not treated as the sole driver. Finally, continuous monitoring, evaluation, and adaptation of the safety program are crucial to ensure its ongoing effectiveness and relevance. Question 15. Upon reviewing the quarterly production targets, the Chief Operations Officer, COO, has instructed the safety manager to temporarily suspend the mandatory lockout/tagout (LOTO) procedures for routine maintenance on a specific line to meet an urgent delivery deadline. The COO emphasizes that this is a one-time exception and that the team is experienced and can manage the risk. Safety manager knows that LOTO is a critical control for preventing unexpected energization and is mandated by OSHA Control of Hazardous Energy Standard 29 CFR 1910-147. What is the most appropriate course of action for the safety manager? Option A. Comply with the COO's directive to avoid conflict and potential repercussions, assuming the risk is manageable due to the team's experience. Option B. Immediately implement the suspension of LOTO procedures as instructed, and then separately document the directive and the potential risks for future reference. Option C. Inform the COO that while LOTO is important, the company's production goals are paramount, and therefore, the procedures will be temporarily relaxed as requested. Option D. Politely but firmly refuse the directive, citing the specific OSHA standard and the unacceptable risk of serious injury or fatality, and propose alternative, albeit less efficient, methods to meet the deadline while maintaining LOTO compliance. The correct answer is D. Politely but firmly refuse the directive, citing the specific OSHA standard and the unacceptable risk of serious injury or fatality, and propose alternative, albeit less efficient, methods to meet the deadline while maintaining LOTO compliance. Explanation. Scenario analysis. This scenario presents a common ethical dilemma where a safety professional is caught between the imperative to uphold safety standards and the pressure to meet production targets, exacerbated by a direct directive from senior leadership that appears to undermine safety protocols. The challenge lies in navigating this conflict while maintaining professional integrity and adhering to the established regulatory framework. The safety professional must recognize that leadership's role in safety culture is paramount. Their actions and pronouncements set the tone and influence the behavior of the entire organization. Correct approach analysis. The correct approach involves escalating the concern through appropriate channels, documenting all communications, and seeking to educate leadership on the potential consequences of their directive. This aligns with the fundamental principles of professional safety practice, which prioritize the prevention of harm and compliance with regulations such as those enforced by OSHA, Occupational Safety and Health Administration, in the U.S. Specifically, OSHA General Duty Clause Section 5(a)(1) of the OSH Act requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. By directly addressing the leadership's directive and proposing alternative solutions that balance safety and production, the safety professional upholds their ethical obligation to protect workers and demonstrates best professional practice by attempting to influence positive change from within the system, rather than passively accepting a potentially hazardous situation. This proactive and communicative approach is essential for fostering a robust safety culture where safety is integrated into all operational decisions. Incorrect approaches analysis. One incorrect approach involves immediately complying with the directive without question. This represents a significant ethical and regulatory failure. It demonstrates a lack of professional courage and a failure to uphold the safety professional's primary responsibility to protect workers. This passive compliance can lead to serious injuries or fatalities, violating OSHA standards and potentially exposing the organization to severe penalties, legal action, and reputational damage. It also signals to the workforce that safety is secondary to production, eroding any existing safety culture. Another incorrect approach is to ignore the directive and continue with existing safety protocols, without any communication or attempt to resolve the conflict with leadership. While the intent might be to maintain safety, this approach is professionally deficient because it fails to address the root cause of the conflict, the leadership's directive. It creates a disconnect between safety management and executive decision-making, hindering the development of a cohesive safety culture. Furthermore, it misses an opportunity to educate leadership and potentially prevent future similar directives. This approach can be seen as abdicating responsibility for influencing organizational behavior and can lead to a perception of insubordination if discovered. A third incorrect approach is to immediately threaten to report the leadership to regulatory authorities without first attempting internal resolution. While regulatory reporting is a necessary tool when internal mechanisms fail, it should not be the first resort. This approach can be seen as confrontational and may damage the working relationship with leadership, making future collaboration on safety initiatives more difficult. It bypasses the opportunity for constructive dialogue and problem solving, which is crucial for long-term safety culture improvement. Ethically, professionals are encouraged to resolve issues internally first, escalating only when necessary. This premature escalation can be perceived as unprofessional and may not achieve the desired outcome of fostering a sustainable safety culture. Professional reasoning. When faced with such a dilemma, a safety professional should employ a structured decision-making process. First, clearly identify the safety hazard and the regulatory implications of the directive. Second, gather all relevant information, including production pressures and safety data. Third, communicate concerns clearly and professionally to the directive-issuing leader, presenting data-driven arguments and proposing alternative solutions that mitigate risks while considering operational needs. Fourth, if the initial communication is unsuccessful, escalate the issue through the established organizational hierarchy, following company policy for reporting safety concerns. Document all communications and actions meticulously. If all internal avenues are exhausted and the risk remains unacceptably high, then consider reporting to the relevant regulatory agency, such as OSHA, as a last resort. This process prioritizes proactive problem solving, ethical conduct, and regulatory compliance. Question 16. Operational review demonstrates that a company is engaging a contractor for a complex construction project involving significant overhead work and the use of specialized equipment. The company's safety department is tasked with ensuring the contractor's adherence to all applicable safety regulations and company policies. Which of the following approaches best fulfills the company's responsibilities for contractor safety management under OSHA regulations? Option A. Informing the contractor of general safety expectations and explicitly stating that all safety responsibilities and liabilities are solely theirs for the duration of the project. Option B. Relying exclusively on the contractor's reported incident rates to gauge their safety performance and intervening only if those rates exceed industry averages. Option C. Conducting a thorough pre-qualification assessment of the contractor's safety program, including review of their written safety plan, training records, and past safety performance, followed by ongoing site inspections and performance monitoring throughout the project. Option D. Accepting the contractor's self-certification that their safety program meets all regulatory requirements and trusting their internal processes to manage safety effectively. The correct answer is C. Conducting a thorough pre-qualification assessment of the contractor's safety program, including review of their written safety plan, training records, and past safety performance, followed by ongoing site inspections and performance monitoring throughout the project. Explanation. This scenario presents a common challenge in contractor safety management, balancing the need for efficient project execution with the imperative to ensure all contracted parties adhere to established safety standards and regulatory requirements. The professional challenge lies in identifying the most effective and compliant method for verifying contractor safety performance without unduly hindering operations or creating legal liabilities. The correct approach represents best professional practice because it directly addresses the core of contractor safety management, as mandated by OSHA General Duty Clause and specific standards related to contractor oversight. It emphasizes proactive verification of a contractor's safety program and their ability to perform work safely, rather than reactive measures. This aligns with the principle of ensuring a safe working environment for all individuals on the worksite, regardless of their employer. Ethically, it upholds the responsibility to protect workers. An incorrect approach that relies solely on the contractor's self-certification without independent verification fails to meet the employer's duty to ensure a safe workplace. This is a regulatory failure because it abdicates responsibility for oversight and could violate OSHA requirements for managing contractor safety. Ethically, it prioritizes convenience over worker safety. Another incorrect approach that focuses only on incident rates after the fact is insufficient. While incident rates are a metric, they are reactive. A robust contractor safety program requires proactive assessment of the contractor systems and capabilities before work begins and ongoing monitoring. Relying solely on post-incident data is a regulatory failure as it does not demonstrate due diligence in preventing hazards. Ethically, it suggests a reactive rather than a preventative safety culture. A third incorrect approach that delegates all safety responsibility to the contractor, assuming they are solely accountable, is a significant regulatory and ethical failure. While contractors have their own responsibilities, the host employer retains a duty to ensure the safety of their worksite and all individuals on it. This delegation is a clear abdication of the host employer's legal and ethical obligations. The professional reasoning process for similar situations should involve a risk-based approach. First, assess the inherent hazards of the work being contracted. Second, evaluate the contractor's proposed safety program and their demonstrated history of safety performance. Third, establish clear contractual safety requirements and communication protocols. Fourth, implement a system for ongoing monitoring and verification of contractor compliance. Finally, maintain open communication and a willingness to intervene if safety deficiencies are identified. This systematic approach ensures compliance and fosters a culture of shared safety responsibility. Question 17. Examination of the data shows that radiation levels in a specific work area are consistently measuring at the upper end of the permissible exposure limits for non-ionizing radiation, but have not exceeded them. Existing control measures, implemented years ago, are in place. Management is concerned about potential production slowdowns if further controls are implemented. As a certified safety professional, what is the most ethically sound and professionally responsible course of action? Option A. Immediately cease all operations in the affected area until a complete overhaul of the radiation-emitting equipment can be performed, regardless of the economic impact. Option B. Continue current operations without modification, as the measured levels are within the established regulatory limits and no immediate danger is indicated. Option C. Rely solely on the existing control measures, assuming they remain adequate, and inform management that no further action is required as long as limits are not exceeded. Option D. Initiate a comprehensive review of existing controls, enhance monitoring protocols, and conduct a detailed risk assessment to determine if upgrades or modifications to controls are necessary to further reduce exposure, even if within current limits. The correct answer is D. Initiate a comprehensive review of existing controls, enhance monitoring protocols, and conduct a detailed risk assessment to determine if upgrades or modifications to controls are necessary to further reduce exposure, even if within current limits. Explanation. Scenario analysis. This scenario presents a professional challenge due to conflicting priorities between immediate operational needs and the long-term health and safety of workers exposed to a potentially hazardous, yet not definitively proven, radiation source. The safety professional must balance the employer's desire for continued operation with their ethical and regulatory obligation to protect employees. The ambiguity of the radiation level, falling within established exposure limits but approaching them, necessitates a proactive and precautionary approach rather than a reactive one. Correct approach analysis. The correct approach, which involves implementing enhanced monitoring, reviewing existing controls, and initiating a comprehensive risk assessment for potential upgrades, represents best professional practice. This aligns with the fundamental principles of the Certified Safety Professional (CSP) Code of Ethics, particularly the duty to protect the health and safety of others. From a regulatory standpoint, this proactive stance is consistent with the general duty clauses found in occupational safety and health regulations, e.g., OSHA General Duty Clause in the U.S., which require employers to provide a workplace free from recognized hazards. It also reflects the ALARA, as low as reasonably achievable, principle often applied in radiation safety, even when exposures are within legal limits. This approach demonstrates due diligence and a commitment to continuous improvement in safety management. Incorrect approach is analysis. One incorrect approach would be to take no immediate action, citing that the current exposure levels are within regulatory limits. This fails to acknowledge the ethical responsibility to prevent harm and the potential for cumulative exposure to lead to adverse health effects over time. It also ignores the spirit of regulations that encourage minimizing exposure. Ethically, this approach prioritizes cost savings or operational convenience over worker well-being, violating the CSP's primary duty. Another incorrect approach would be to immediately shut down operations without further investigation. While seemingly protective, this is an overreaction that may not be justified by the data. It could lead to significant economic disruption and may not be the most efficient or effective way to manage the risk. This approach bypasses the necessary step of a thorough risk assessment and control evaluation, which is a core competency for a CSP. A third incorrect approach would be to rely solely on the existing, potentially outdated, control measures without reevaluation. This assumes that current controls are adequate for all foreseeable circumstances and does not account for potential degradation of equipment, changes in work practices, or new scientific understanding of radiation effects. It represents a failure in the systematic approach to hazard management and a lack of proactive risk mitigation. Professional reasoning. When faced with such a situation, a safety professional should follow a structured decision-making process. 1. Data interpretation. Thoroughly analyze all available data, understanding its limitations and implications. 2. Risk assessment. Conduct a comprehensive risk assessment considering the likelihood and severity of potential harm from the identified hazard. 3. Control evaluation. Review existing controls for effectiveness and identify potential gaps. 4. Hierarchy of controls. Apply the hierarchy of controls, elimination, substitution, engineering controls, administrative controls, PPE, to develop appropriate mitigation strategies. 5. Regulatory compliance. Ensure all proposed actions meet or exceed regulatory requirements. 6. Ethical consideration. Prioritize worker health and safety, acting with integrity and due diligence. 7. Communication. Clearly communicate findings, recommendations, and actions to management and affected employees. 8. Continuous improvement. Establish mechanisms for ongoing monitoring and reevaluation of risks and controls. Question 18. Performance analysis shows a recurring incident of minor skin irritations and respiratory discomfort among workers in a specific production area due to exposure to a chemical solvent. The current safety program primarily relies on providing detailed training on safe handling procedures and mandating the use of specific respirators and chemical-resistant gloves for all personnel entering the area. The safety manager is considering whether to invest in a new ventilation system or to enhance the existing training program and procure higher-grade PPE. Option A. Implement a strict rotation schedule for workers in the affected area to minimize individual exposure duration and reinforce existing safe handling procedures through daily toolbox talks. Option B. Prioritize investigating the feasibility of substituting the chemical solvent with a less hazardous alternative or redesigning the process to eliminate its use. And if not fully achievable, explore engineering controls like local exhaust ventilation before considering enhanced PPE and administrative controls. Option C. Focus on developing more comprehensive training modules on the hazards of the solvent and the correct usage of existing PPE, and procure upgraded respirators and gloves to provide a higher level of protection. Option D. Immediately replace the current chemical solvent with a readily available, less expensive alternative, without conducting a thorough risk assessment of the new substance. The correct answer is B. Prioritize investigating the feasibility of substituting the chemical solvent with a less hazardous alternative or redesigning the process to eliminate its use. And if not fully achievable, explore engineering controls like local exhaust ventilation before considering enhanced PPE and administrative controls. Explanation. This scenario is professionally challenging because it requires a safety professional to balance immediate operational needs with long-term risk reduction, while adhering to the established hierarchy of controls. The pressure to maintain production can lead to shortcuts or a premature reliance on less effective control measures. Careful judgment is required to ensure that the chosen controls are not only compliant, but also genuinely effective in mitigating the identified hazard. The correct approach represents best professional practice because it prioritizes the most effective and sustainable methods of hazard control, as mandated by regulatory frameworks such as OSHA General Duty Clause and specific standards related to hazard communication and personal protective equipment. By starting with elimination and substitution, the safety professional is adhering to the fundamental principles of risk management, aiming to remove the hazard at its source or replace it with a less hazardous alternative. This proactive stance minimizes the potential for exposure and reduces reliance on human behavior or the limitations of PPE. Ethically, this approach demonstrates a commitment to worker well-being by seeking the most robust protection. An incorrect approach that relies solely on administrative controls fails to adequately address the inherent risk of the hazard. While administrative controls like training and work procedures are important, they are considered less effective than engineering solutions because they depend heavily on worker compliance and can be prone to human error. This approach could be seen as a violation of the employer's responsibility to provide a safe workplace, potentially contravening OSHA standards that emphasize the implementation of higher-level controls when feasible. Another incorrect approach that focuses exclusively on personal protective equipment, PPE, is also professionally unacceptable. PPE is considered the last line of defense and should only be used when other controls are not feasible or as a supplementary measure. Relying solely on PPE can create a false sense of security, and its effectiveness is contingent on proper selection, fit, maintenance, and consistent use by all employees. This can lead to regulatory noncompliance with OSHA PPE standards, which require employers to assess hazards and implement appropriate controls, including engineering and administrative measures, before resorting to PPE. The professional reasoning process for similar situations should involve a systematic hazard assessment, followed by a thorough evaluation of control options against the hierarchy of controls. This includes exploring elimination and substitution possibilities first. If these are not feasible, then engineering controls should be investigated. Administrative controls should be considered next, and PPE should be reserved for situations where higher-level controls are insufficient or impractical. The decision-making process must be documented, justified by risk assessment data, and communicated to relevant stakeholders, ensuring that the chosen controls are the most effective and compliant means of protecting workers. Question 19. Strategic planning requires a comprehensive understanding of chemical properties and reactivity to prevent catastrophic incidents. A chemical plant is storing several reactive chemicals in proximity, which approach best ensures the safety of personnel and the facility, adhering strictly to U.S. regulatory frameworks for process safety. Option A. Focusing primarily on the immediate hazards of each chemical in isolation, such as acute toxicity and corrosivity, and ensuring adequate ventilation and personal protective equipment for each. Option B. Conducting a detailed reactivity hazard assessment that considers potential interactions, exothermic reactions, decomposition, and polymerization under various process and storage conditions, and implementing appropriate controls based on this assessment. Option C. Prioritizing cost-effective storage solutions and minimizing the number of safety studies conducted to reduce overall project expenses, as long as basic chemical segregation is maintained. Option D. Relying solely on the flammability and toxicity data provided on the safety data sheets, SDS, for each individual chemical, assuming that if these are managed, reactivity risks are mitigated. The correct answer is B. Conducting a detailed reactivity hazard assessment that considers potential interactions, exothermic reactions, decomposition, and polymerization under various process and storage conditions, and implementing appropriate controls based on this assessment. Explanation. This scenario is professionally challenging because it requires a safety professional to move beyond simply identifying hazards to proactively managing the complex interactions between chemicals, which can lead to unforeseen and potentially catastrophic events. The challenge lies in anticipating reactivity under various conditions, not just static storage. Careful judgment is required to assess the likelihood and severity of reactive incidents, considering factors like temperature, pressure, presence of contaminants, and scale of operations. The correct approach represents best professional practice because it aligns with the fundamental principles of process safety management and hazard analysis mandated by U.S. regulations, specifically OSHA Process Safety Management, PSM, Standard 29 CFR 1910, 119. This standard requires employers to identify, evaluate, and control process hazards. A thorough reactivity hazard assessment, which includes understanding the chemical properties and potential for exothermic reactions, decomposition, or polymerization, is a critical component of this. By considering the potential for runaway reactions and implementing appropriate engineering and administrative controls, the safety professional is fulfilling their ethical and regulatory duty to protect workers and the environment. This proactive stance is essential for preventing incidents. An incorrect approach that focuses solely on the immediate flammability or toxicity of individual chemicals fails to address the inherent risks associated with their potential interactions. This is a regulatory failure under OSHA PSM standard, which explicitly requires consideration of reactivity hazards. Ethically, it represents a dereliction of duty by overlooking significant risks that could lead to severe harm. Another incorrect approach that relies only on generic safety data sheet, SDS, information without conducting a specific process-based reactivity assessment is also problematic. While SDSs provide valuable information, they often do not detail the specific conditions or quantities present in a particular process. This can lead to a false sense of security and a failure to implement necessary controls, violating the spirit and intent of hazard identification and risk assessment regulations. A third incorrect approach that prioritizes cost savings over a comprehensive reactivity assessment is a clear ethical and regulatory failure. OSHA PSM standard and general duty clause require employers to provide a workplace free from recognized hazards. Prioritizing financial considerations over safety in the face of known or potentially discoverable reactivity hazards is unacceptable and can lead to severe penalties, and more importantly, loss of life or serious injury. The professional decision-making process for similar situations should involve a systematic approach to hazard identification and risk assessment. This includes 1. Understanding the specific chemicals involved and their inherent properties. 2. Conducting a thorough process hazard analysis (FA) that specifically addresses chemical reactivity under process conditions, including potential deviations. 3. Consulting relevant literature, databases, and expert opinions for information on chemical incompatibilities and reactivity. 4. Implementing a hierarchy of controls, prioritizing elimination or substitution, followed by engineering controls, administrative controls, and finally, personal protective equipment. 5. Regularly reviewing and updating assessments as processes change or new information becomes available. Question 20. Analysis of a manufacturing facility safety program reveals a significant gap in employee engagement with hazard identification and risk mitigation efforts. The safety manager is tasked with developing a new strategy to enhance employee involvement, ensuring compliance with U.S. occupational safety and health regulations. Which of the following approaches would best align with regulatory expectations and promote a proactive safety culture? Option A. Designate specific employees as safety champions who are responsible for observing their colleagues and reporting any unsafe behaviors directly to management. Option B. Conduct periodic safety audits and inspections solely by the safety department and management, with findings communicated to employees through bulletin boards. Option C. Establish a formal process for employees to report hazards and near misses without fear of reprisal. Create cross-functional safety committees with employee representation to review safety data and recommend improvements, and involve employees in incident investigations. Option D. Implement a mandatory annual safety training session for all employees, focusing on company policies and procedures, and require employees to sign off on their understanding of these materials. The correct answer is C. Establish a formal process for employees to report hazards and near misses without fear of reprisal. Create cross-functional safety committees with employee representation to review safety data and recommend improvements, and involve employees in incident investigations. Explanation. This scenario presents a professional challenge because it requires a safety professional to balance the need for robust employee involvement in safety programs with the practical limitations of time and resources, while strictly adhering to U.S. regulatory frameworks, specifically OSHA General Duty Clause and various specific standards that mandate or encourage employee participation. The challenge lies in designing and implementing an effective employee involvement strategy that is not merely a perfunctory exercise, but genuinely contributes to hazard identification, risk assessment, and control measure development, thereby fostering a proactive safety culture. Careful judgment is required to ensure that the chosen methods of involvement are accessible, meaningful, and lead to tangible improvements in workplace safety, aligning with the spirit and letter of OSHA regulations. The correct approach represents best professional practice because it directly addresses the core principles of effective employee involvement as understood within the U.S. regulatory context. By establishing a formal mechanism for employees to report hazards without fear of reprisal, participate in safety committees, and contribute to incident investigations, the safety professional is proactively fulfilling OSHA expectations. This approach fosters a culture of shared responsibility for safety, which is a cornerstone of effective safety management systems and is implicitly or explicitly supported by numerous OSHA standards. It also aligns with the ethical obligation to protect workers by empowering them to be active participants in their own safety. An incorrect approach that focuses solely on post-incident reporting by employees without proactive hazard identification or participation in safety program development fails to meet the comprehensive requirements for employee involvement. This approach is ethically deficient as it places the burden of safety primarily on reactive measures rather than preventative ones, and it may violate the spirit of OSHA emphasis on proactive safety management. It also misses opportunities to leverage the invaluable frontline knowledge employees possess for hazard recognition and control. Another incorrect approach that relies exclusively on management-led safety training, with minimal or no opportunity for employee feedback or input into the training content or safety procedures, is also professionally unacceptable. While training is crucial, it becomes less effective if it is not informed by employee experiences and concerns. This approach can lead to a disconnect between management's perception of safety and the reality on the shop floor, potentially creating overlooked hazards. Ethically, it fails to fully engage employees in their own safety and may not comply with standards that require employee input in developing and implementing safety programs. A third incorrect approach that involves employees only in the final approval of safety policies, without their prior input during the development or review stages, is also flawed. This rubber stamping approach does not constitute meaningful involvement. It fails to harness the collective intelligence and experience of the workforce in identifying potential issues or suggesting improvements before policies are finalized. This can lead to policies that are impractical, ineffective, or even create new hazards, and it falls short of the proactive and participatory approach encouraged by OSHA. The professional reasoning process for similar situations should involve a systematic assessment of existing safety programs, identification of gaps in employee involvement, and the development of a multifaceted strategy that incorporates various levels and types of participation. This process should be guided by an understanding of relevant OSHA standards, industry best practices, and the specific operational context of the workplace. Professionals should prioritize methods that empower employees, ensure their voices are heard and acted upon, and foster a continuous improvement cycle in safety performance. This involves not only establishing formal mechanisms, but also cultivating a supportive organizational culture where employee involvement in safety is valued and encouraged.